Douglas here from Ignite Labs. In this video demonstration, I'm going to be walking you through exercise 12 of the second Capture the Flag challenge offered by InfosecInstitute. Now, the URL for this is ctf.infosecinstitute.com/ctf2, and you can access the levels by clicking the levels drop-down menu in the top left-hand side and going down to level 12. When you do, it looks like we're presented with a simple login form here for a username and password, and the hint says your task is to crack the password for the user called admin. Okay, so they gave us 50% of the credential right there. Use whatever tool that you like, but we recommend entering Google and searching for, and then they give us a Google Dork to search for, most likely a password file that contains the password because it's recommended. So let's just copy and paste that Google Dork right in here. And I'm just going to download the very first file that gets returned. And now it said that you can use whichever tool that you wish. I'm going to simply use Bash. And the reason why I'm going to do that is I used it last time as well because I want this to be an actual lesson. I want you to actually learn exactly what's happening. Now, this doesn't mimic something like Medusa or anything that's advanced that's going to thread a whole bunch of requests. This is simply going to be a very generic brute force dictionary attack script that we're going to write. And I'm going to make it very, very easy. So don't just exit the video right away. Please watch through. It's very easy. So let's just open up a terminal here, and I'm going to create a workspace here, which is simply a directory called temp. Okay, cd into temp. And now I'm going to use wget to download the file, which I had just copied the URL from in Google Chrome. And I'm going to move that file to a sane file name, which is simply passwords.txt. And then the next thing we want to do is we want to analyze password.txt and remove any lines that aren't actually passwords or valid passwords. I mean, I guess some of these could be passwords, but we want to get rid of these huge lines right here in hopes that, first of all, they didn't use this entire line as a password, and to cut back on the amount of HTTP requests done during the actual brute force attempt. Look, there was a blank space I just got rid of down there as well. You want to, whenever you're doing a web application penetration test and you're trying to brute force a login form, like say for a Cisco router or some sort of other network device that has an administrative panel like a Mitel phone or something like that, whenever you type in the wrong password, you're most likely presented with a different HTTP response, such as 403, for forbidden, or even a 500 error I've seen sometimes on some devices. But with this is most likely going to produce a 200 every single time. And before we actually start coding, I'm going to analyze the actual form and show you exactly what the form does. We're going to look at the actual handler of the form, and we're going to watch the network traffic whenever we enter invalid credentials. And we also need to know for the response, since it's both 200 for a success or a failure, we're going to have to actually just look through all of the lines of the HTML for every single response and look for some sort of unique string that only shows up whenever there is a success. For instance, whenever we finish any of the other exercises in the second CTF challenge here, we've noticed that there's been a theme where a green box shows up that shows us and says, congratulations, you've finished this challenge, or you know the drill, or something like that. And I know for a fact that that is going to most likely have a class, a CSS style class or something in it that we can actually use to search for. And if that gets returned in the HTTP response as in the HTML, then we know to stop our brute force application. We know that we did in fact enter the correct password. So let's go back to the form here. We're going to look at this form here. I'm going to right-click anywhere in the form and go to Inspect Element. There are two ways you could do this. Now, there's an insanely quick shortcut, which is by simply watching the network traffic here and typing in invalid credentials. Or there's the long way, which means you go through the elements and you actually see that the form method is in fact post and that the handler is in fact action nothing, which means that ex12.php is going to handle the form submission. So whenever it gets submitted, it's actually going to handle the response from it rather. Now the network way we're going to use just simply because we know this is a CTF challenge and we know that they're most likely not, even watching the traffic. So let's just type in an incorrect. We're going to use admin password 123, and we're going to type in incorrect credentials here, hit login, and we're actually going to watch to see what happens. Now we see that ex12.php was in fact called, and look, exactly as I suspected, the status returned from the HTTP response is 200 OK. So if you click on this here, rather than go through the form as I just showed you, you can scroll all the way down to the bottom to view the form data from the headers. And this is very cool because this is a really good shortcut. If we click View Source, this string right here is exactly what we're going to pass in our script to this form handler right here for every single password found in passwords.txt. Now how do we do that? Well, we're going to use bash, like I said. So let's do vim bf.sh, bf for brute force. The very first line is going to be a shebang, and then our interpreter. And our interpreter is going to be bin bash, and we're going to start off with a simple for loop, for I in, and then we're going to use some PEMDAS-like syntax. If you can remember PEMDAS from your algebra years, you know that this is going to be executed first. So cat passwords .txt. This most likely isn't the most efficient method, but it gets the job done, and you can actually see what's happening here. And then we're going to do. And inside do, we're going to do printf, and we're going to printf trying password, and we're going to put a sigil, and then I, and then a new line character. This new line meta character right here is going to print the new line, and then this sigil I is going to be every single line in here. And we're going to prove that by just running it. Done. And actually we don't need the semicolon if it's just on a single line like that. So let's just exit this right here by WQ for writing and quitting. And we're going to make this an executable by using chmod +x bf.sh. Now we do ls, so we see that bf.sh was in fact turned green. ls-l will actually show the actual permissions here, that it does in fact become an executable. So let's go ahead and run that. It's not going to do anything except what we see here, trying password, and now we know for a fact that the $I variable actually becomes the password for every single line in the file, which is exactly what we wanted. So let's go back into the file here. And we actually want to do a little bit more than just printf, obviously. But what I'm going to do is I'm going to do something a little bit, I'm going to do a little bash trick here, and I'm actually just going to print a special string here that's going to turn the text red. 0, I think it's 31M. Okay, so now if we do trying password, it should turn red. Now it's going to turn the whole shell red, so after we exit the application, we're going to want to turn it back to the actual color in which it was, and I think the easiest way to do that is to use 00M. This syntax for these little strings here are very weird, and I don't think I've ever memorized them before, so I feel lucky right now. Yes, it did turn red, and now when the script ends, I see our shell turns back to the normal color, which is exactly what we wanted. Now, why do we turn that red? Well, we're just going to use red for trying password and the actual password, and then we're actually going to use green for output. Okay, so this is our bash script so far. For every single line, we saw that the output is trying password : space and then the password. So what do we want to do with this password? Well, we want to actually make an HTTP request. And what we're going to use to do that is curl or curl. And we want to make curl silent, and we're going to pass data into curl. Now, one thing to know about curl is that whenever you make an HTTP request for it, like I said before, what we want to come back is actual HTML code. That way we can search for that specific string alert-success, which is exactly what this is here. And I know that for a fact because I've done this before already. So let's go down to level 4. As you see, it was highlighted here. And I know this was a very simple exercise here. So I'm going to just simply complete this challenge quickly so I could show you the output of that green box. The reason why we want to use the green box is because, like I said, a unique string is going to come back only upon success, and it's probably the easiest way to do this. So I remember this was HTTP, and it was case insensitive, and the URL we wanted to go to was this here, the domain rather, 2.txt, and I think we just add the PHP extension. I'm going to copy this here. Yes, okay, so I'm going to right click in the green here and go to inspect element, and we're going to check this element, and we're going to see that alert-success is in fact a CSS class that only shows up upon an actual completion of one of the levels here. So we're going to use alert-success as the actual string that we want to search for. So if curl is returning HTML code, I could just simply use grep-i and then search for alert-success. success. We don't really even need the hyphen I for case insensitive because we know that what's coming back is all lowercase. But just to be safe, I'm going to put that in there. And one thing to know about curl is that you don't use this kind of syntax or use the equal symbol. You want to put a space here. And I know that kind of sucks, but a lot of open source projects are all just so different from each other that after using the terminal for so many years, you'll actually get used to all these quirks and stuff, and you'll be able to analyze output a lot faster, and troubleshooting becomes much easier also. Anyways, okay, so I want to just grab this string quickly here that was passed in the headers here. Let's see, view source, and then we're going to copy this string right here. This string is the form data that, again, we want to pass to ex12.php. So let's put in our form data here. I copied it and I'm pasting it in here. And now, one thing to note is that we don't want to, for every single password here, we obviously don't want to pass the password123 every time. We want to try the password that actually is in the variable I. So just change the actual password right there, $I. And we actually need to set the handler, or the URL that we want to call, rather. So we copy this here, and we minimize it, and we're going to paste that right in here. Okay, so this script is pretty much done. I mean, it's going to show any output that's going to show alert success, but it's not very smart. Like if we walked away from this, we could very potentially, if there are hundreds and hundreds of passwords in passwords.txt, we could very well miss the actual output and have to scroll up really far, and it could actually go beyond the buffer of our terminal emulator. So what I'm going to do is I'm going to assign this to a variable. So I'm going to assign it to return data equals, and then we're going to use that same PEMDAS-like syntax, which is a sigil and then parentheses. And like I said, this will execute. This entire command right here will be executed, and then the value output will be assigned to the variable return data. Now, all we have to do now is simply check return data not equals nothing. And we use this syntax here with the exclamation point equal symbol because this is in fact a string. Now if it doesn't return nothing, that means there was a successful login. So we want to do printf, the password was I. And then we want to do exit, because we want to exit this for loop right here because we don't want to keep going. We don't want flow through in the application. We actually want to stop. And actually, I forgot to put something here. Whenever you write if, you have to write then also. And then we want to do 5 to complete the if. Actually put this back here so it matches this for do type of tab indentation here. So the password was I, and then exit. And what else could we do? We can make this green. How about that? We do printf, and then we do one of these silly codes right here, 0:32M. And when we exit, we still want to do this right here and return the terminal back to its normal color. Now this is an entire script right here. It's a little bit smarter now than simply just printing out whether or not something gets returned upon success. Okay, so let's troubleshoot it. Now that we've written it, we obviously need to troubleshoot it. So ./bf.sh to run it, and it looks like no troubleshooting is actually needed. Okay, so what I'm going to do is I'm going to pause this video now, and when we come back, there should only be two outcomes. Either we see green text that says the password was, and shows the password, and it should stop, or we'll see the end of the file, which means a bunch of red text, and then it just exits. Hey, look at that. The password was cracked, and it is princess. Okay, that's pretty cool. So it looks like our script worked perfectly. Let's go ahead and test it in the exercise here and see if that is right. Admin princess. Yay, look at that. You certainly know how to crack a password. Upcoming redirect. Okay, great. So quickly, I want to just explain this shell script one more time. So this is the interpreter here. This for loop will assign every single line inside passwords.txt to I in a very sequential order. So basically the very first password, say it's password 1, will become I, and then you can access I using a sigil here, as we do right here. So trying password I, and then we access it again here, and we put it into the form data that gets passed to ex12.php, this right here, and then we grep for the actual success string. Let's see, so the return data is actually, all of this gets assigned to return data, so then we just simply grep return data, or I'm sorry, we basically search grep, so then we search return data for nothing, and if it does actually equal something, if something gets printed out, then basically then we search return data and make sure that it does not equal nothing. If it does not equal nothing, then we have a success, and we print the password by accessing it yet again in printf with the $symbol I. And again, these stupid little codes right here, just basically, they don't need to be there. They just basically make the output a different color. And what we want to do is this code right here, and then this code again right here, basically is going to return the shell to its normal color. So that's it. That's how we crack the password by hand. And basically, again, this isn't an advanced brute force dictionary attack tool like Medusa or something that's HTTP Hydra or whatever the applications are that people use, because those are threaded, and most likely the threads go out, multiple HTTP requests happen at a time, so they're a much faster, much noisier way of attacking a web form. Thank you for watching.